Hi, in this video I'll talk about this paper called Learning to Rank from Pairwise Approach to Listwise Approach. So first we need to understand what learning to rank is. So learning to rank is a major development in the document retrieval research. So it talks about assigning a relevance score for a given set of n documents when it's applied to a ranking function given a query, and it ranks the document in a decreasing order of their relevance score. So in previous there was a pairwise approach that was first introduced. So in pairwise approach, for a given n number of documents, so relevance score is computed for all possible combinations of the pairs of the documents when the order is important. So since the number of pairs can be order of factorial, so this is computationally intractable, and also this does not consider the listwise relevance that is present in the actual retrieval process. So in this paper, the authors have suggested a listwise approach, and the loss functions for dealing with the listwise relevance score when presented aside the ground truth. So the authors suggested a probabilistic model based on this given formula of the probability of computing the all possible number of the order of the documents that are presented, and then they have showed that the following probability is not computationally tractable. So they have alternatively suggested a second probability to compute the top one probability of the given J document being the rank 1 document, and this makes the whole computation very easy. And author suggested the following algorithm, which is based on the neural network, and for a given xi is comprised of the query and the document tuple, and this is fed into a neural network, and consecutively the loss function and the gradient updations are followed. In the next part, I will briefly show the mathematical notations, and then I'll jump to the code. In this part, I will briefly explain the mathematical notations. Those are mentioned in the paper. So here Q is represented as a set of m number of queries, and each ith query has n number of documents, and for the time being I have assumed that each ith query has equal number of documents which are associated with it, and yi being the corresponding ground truth relevance score of the each individual di, and S1 up to Sn and the ground and the ranking function predicted the relevance score. And author showed that there are n factorial permutations possible for a given n number of documents, and if we predict the order of this d1, d2 up to dn probabilities, so this can be termed as a product of this each individual quantity. So these are nothing but the probability of being at the jth position. So since computing this n factorial number of probabilities are not computationally tractable, the author suggested a top one probability. So this Pj denoted as a probability of the jth document being at the rank 1 document is denoted by this e to the power sj divided by summation of k equals to 1 to n e to the power sk. So this can be recalled as a softmax function. So next, the ranking function. The author suggested a neural network based ranking function. So for a given q1 query, and there are n number of documents d1 up to dn, and the ground truth labels are denoted as this y1 up to yn. So we will have to somehow map this q1 and the d1 to this y1, and to feed into the neural network, we will regard this q1 and the d1, q1 and the dj as a form of tuple, and okay, and then we'll feed into a basic neural network as a ranking function of our learning to rank problem. So at the end of it, there are S1 up to Sn. These are scores that are generated by the ranking function. So these are not normalized. To normalize this, the author suggested, like in the top one probability method, we'll have to apply the softmax function at the end of it, and eventually we'll get two probability distribution, and we have to compute the loss function based on this two probability distribution. And all the proofs of the lemma and the theorems are well documented in the paper, so I'll suggest kindly go through it. And In the next section I'll briefly show the code of this of the paper. Next, I will implement the ListNet. To implement the ListNet, I need to have basic libraries to be installed on our system. So first, we need sentence transformers to be installed to get the embeddings of the queries and the documents. And these are all the basic imports. And this is the data set that we will train our model on. So first, we have for a given query, there are 5 documents which are relevant, are present in the decreasing order of their relevance score. So there are total number of 10 documents, and these are all the relevance grades. And since we know the sentence transformers generates an embedding of dimension 384, and to get the q comma d tuple, we need to concatenate the query and the document vector along the row wise to get the 768 dimension, which is 384 plus 384 when being concatenated in a row wise fashion. And this is the custom data loader, and the batch size should be the total number of documents in a given query. And this is our ListNet architecture. So this is a custom ListNet. This is totally a DIY neural network. You can use your own. So, and the loss function I have used is a KL divergence loss, but in the paper they have used the categorical cross entropy. So I have used the KL divergence loss since we are dealing with the two distributions of the probabilities. So KL divergence will be useful in this case. So this is a training loop. The optimizer I have used the Adam optimizer with the learning rate of 0.01, and I have trained the neural network for the 50 epochs, and the loss function, as you can see, is gradually being decreased. And this is the ground truth of the relevance grade of the first 5 documents, and this is the predicted probabilities of the first 5 documents. So you can see the probabilities are almost similar because our data set is quite small and the model is naturally overfitted. So you can use this notebook to get an idea about how to train the ListNet on your custom dataset, and you can experiment with the ListNet architecture of your requirement, and that is it. You can let me know if you find this video very useful or not in the comment section below, and like, share and subscribe if you like it. Thank you.